Welcome students. Today video number 4 in first chapter Coulomb's law and electric field. This is video number 4. In this video we read about the intensity of electric field at any point due to electric dipole. For this there are two positions. First is end-on position and second is broadside on position. End-on position is also called on the axis of the dipole. So we read about end-on position. End-on position. End-on position is that when we take any point on the axis of the dipole, this is called end-on position. Suppose this is any electric dipole. This is any electric dipole which is made of minus q and plus q charge, and distance between them is 2L. This is any electric dipole. Suppose this is any electric dipole which is made of minus q and plus q charge, and distance between them is 2L. This is electric dipole AB, and it is placed in a medium whose dielectric constant is K, and C is any point at a distance R from middle point O of the dipole, at which we have to find out the intensity of electric field. When we take any point on the axis of the dipole, either right side or left side, then this is called end-on position. Now we find out the intensity at this point. So first we find out the intensity at this point due to plus q charge. The intensity is due to plus q charge. Intensity, that is E1 is equal to 1 upon 4 pi epsilon naught K Q upon this distance R. This is R minus L. This is L because O is middle point. This distance is 2L. So this distance is R minus L ka whole square. This is the intensity of electric field at this point due to this charge, and the direction is just away from charge, E1. Just away from charge, because you know that the intensity of electric field at any point due to plus q charge is just away from charge. Now the intensity of electric field at point C due to minus q charge. Minus q charge, E2 is 1 upon 4 pi epsilon naught K Q upon this distance, that is R plus L ka whole square, that is. And the direction of E2 is toward the charge. The intensity at any point due to negative charge is toward the charge. Direction is this. Since E1 E2 are in opposite direction, that is why the resultant intensity at point C is E is equal to E1 minus E2. E1 is greater than E2 because this distance is small as compared to this distance, and intensity is inversely proportional to the square of the distance. That is why E1 is greater than E2. So E is equal to, now solve it, 1 upon 4 pi epsilon naught K Q upon R minus L ka whole square minus 1 upon 4 pi epsilon naught K Q upon R plus L ka whole square. So E is equal to, taking common, 1 upon 4 pi epsilon naught K Q 1 upon R minus L ka whole square and minus 1 upon R plus L ka whole square. Taking LCM, 1 upon 4 pi epsilon naught K Q upon, taking LCM, R square minus L square ka whole square, that is R minus R plus L ka whole square minus R minus L ka whole square, and solving we get 1 upon 4 pi epsilon naught K Q. When we solve it, that is 2 R L upon R square minus L square ka whole square. Q into 2L, that is P, is equal to 1 upon 4 pi epsilon naught K Q into 2L, that is called P, electric dipole moment, upon R square minus L square ka whole square. Since the value of L is very greater than R is very greater than 2L, because the distance is very small as compared to this, so we can take L tending to 0. So the intensity E is equal to 1 upon 4 pi epsilon naught K P R upon R ki power 4, and R cancel out. So the intensity, the final is E is equal to 1 upon 4 pi epsilon naught K P upon R cube. P upon Q into 2L, that is 4RL, not 2RL, 4RL. 2PR, 2P, that is 2P upon R cube. And for air or vacuum, the value of K is 1. So E is equal to 1 upon 4 pi epsilon naught P upon R cube. 2P upon R cube, that is final answer. This is the intensity of electric field at any point due to electric dipole and on position. Now, broadside on position, second is broadside on position. Broadside on position, when we take any point on to the perpendicular of electric dipole, that is called broadside on position, or on the equatorial line. Broadside on position. Broadside on position. Suppose any electric dipole, this is any electric dipole which is made of minus q and plus q charge, and distance between them is 2L. It is placed in a medium whose dielectric constant is K, and C is any point at a distance R from middle point O of the dipole. This distance is L. Middle point O of the dipole, this point is O, L, at which we have to find out the intensity of electric field. Now we find out the intensity of electric field at point C due to plus Q charge. For this we have to take this distance, that is under root R square plus L square, and this distance is also under root R square plus L square. So now the intensity of electric field at point C due to plus Q charge, that is E1. E1 is equal to 1 upon 4 pi epsilon naught K Q upon the square of the distance R square plus L square. And the intensity of electric field at point C due to minus Q charge, E2 is plus Q charge, due to minus Q charge, 1 upon 4 pi epsilon naught K Q upon R square plus L square. They are same, but the direction is due to plus Q charge. The direction of E1 is this, just away from charge, E1, and E2 is toward the charge. Since E1 E2 are different directions, then how we find out their resultant? For this we let this angle is theta. So this angle is also theta because this distance is same, isocyclic triangle. And when we draw a line parallel to AB, this angle is also theta, alternate angle, and this angle is also theta, conjugate angle, and the angle between E1 and E2 is 2 theta. And when two vectors make angle with each other, then the resultant E is equal to under root E1 square plus E2 square plus 2 E1 E2 cos 2 theta. With this method we can find out the resultant intensity. But since E1 is equal to E2, that is why we can take under root E1 square, E2 in place of E2 we put E1 square, 2 E1 square cos 2 theta. E is equal to under root 2 E1 square plus 2 E1 square cos 2 theta. Take common 2 E1 square, 1 plus cos 2 theta. Now E is equal to under root 2E square E1 square 1 plus 2 cos square theta minus 1. This is the formula of cos 2 theta. Now to cancel out 1 cancel out. E is equal to under root 4 E1 square cos square theta when we take root 2 E1 cos theta. by putting the value of E1 1 upon 4 pi epsilon naught K Q upon R square plus L square, and the value of cos theta we can take L upon under root from this triangle, a triangle CAOR, CBO. Cos theta is equal to L upon perpendicular upon hypotenuse. L upon under root R square plus L square, R L upon. So we can take L upon under root R square plus L square. QL is P 1 upon 4 pi epsilon naught K P upon R square plus L square की power 3 by 2. Since the value of R is very greater than 12, we can take L tending to 0. So E is equal to, we get 1 upon 4 pi epsilon naught K P upon R cube. This is final formula, and for air we get put K is equal to 1. So we get E is equal to 1 upon 4 pi. Final formula E is equal to 1 upon 4 pi epsilon naught P upon R cube. This is the intensity of electric field at point C due to this electric dipole, and the direction of this resultant is this. So when two vectors are equal to each other, their resultant bisect the angle between them. So the direction of the resultant is this, that is